Hey guys, this is Kendall Terry, and this is looking at the immune system, specifically the introduction to that today. And the first thing we're looking at is non-specific defense. Non-specific meaning that it's a barrier, like it's identified here, or it's some kind of just general way to prevent things from getting into the body or prevent pathogens from causing disease to the body. The first line of non-specific defense are things like the skin, the mucous membranes, and then the secretions that those produce. So the skin and mucous membranes just creates a physical barrier. It's a covering that something would have to get through to actually get into the body. They also secrete things like sweat, lysozyme in some of those mucus type things as well that break down the proteins. So the sweat will lower the pH, and lower pH, bacteria may not be able to survive. So you've got these types of things. It's kind of that first line or wall or whatever you want to look at it as that keeps stuff from getting into the body. And this also includes the alimentary canal that is our digestive tract that many times we think of as being inside the body, but that tract is technically an outside area that these align to keep stuff from getting through there as well. The second line of defense is the phagocytic white blood cells. These are the ones that will go around and just eat everything that's not part of your body. The antimicrobial proteins, these are proteins that your body produces that will help destroy bacteria as well. And then the inflammatory response. And we're going to take a little bit of time to look at what that actually means. So when we're considering the inflammatory response, there's 4 steps. The first is when the puncture actually does go through the skin. So this could be anything from a needle or a pinprick or just a paper cut to even more severe stuff where there's something needed other than just the body's way of healing. Maybe you need stitches or something like that. But it's still the same. So you get some kind of pathogen or bacteria that's going to enter the body at that point. These cells in here, when this happens, will release chemicals. Chemicals like histamine and prostaglandins, and those will cause the next couple steps to take place. Then you go to this one here, so no longer is that there, whatever made the break in the skin, but you still have the pathogens that are there that need to be taken care of. So the capillaries, here's a blood capillary, will dilate, get bigger, and fluid and clotting elements will move over from the blood into that area. So you've got things that are in the blood that are going to start to migrate out of the vessel whenever those capillaries dilate. Now this will cause swelling to take place at that wound area, as well as an increase in temperature, a reddening because of what's going on as well. All of that is because of the inflammatory response. Then we have the next step where you can see that wound is starting to be healed by those the platelets and things like that are in the blood and the clotting factors that are in there. And then you have the bacteria here still there, but phagocytic cells are being attracted to those. So you see they're going after them, they're getting ready to consume those to try to not let any of them past this point right here. We definitely don't want them to get into the blood. We don't want them to infect any of these cells around here any more than they already have. Then you get into the fourth. So you got the phagocytic cells are actually consuming those pathogens, and cell debris in tissue is going to heal then as all that begins to get less and less, and eventually it'll be completely healed. So now let's look at the specific immunity. In specific immunity, you have primarily your lymphocytes. Your lymphocytes, you got 2 types. You've got B lymphocytes and T lymphocytes. We many times refer to these as B cells and T cells. And these are part of your white blood cells that are going to attack the antigens and pathogens that enter the body. An antigen is a foreign molecule that elicits a specific response by a lymphocyte. It may be a part of a bacteria, or it could just be a receptor on the outside of the bacterial wall. There's many different things that could serve as antigens. Those antigens will have specific antigen receptors. So here you've got different antigens, and they have different receptors. Okay? And these receptors are located on B cells. Now we know that these are B cells because of this Y-shaped receptor. In a T cell, it just got one receptor. It doesn't have a Y receptor. So there's a difference there. So anytime you see that Y, you know it came from a B cell. So when we look at that response, using this specific response, we're going to look at two different things. We're going to look at primary and secondary response. In the primary response, that's when the antigen is first recognized by a B cell. That will cause what we call clonal selection to occur, where this cell will literally clone itself many times over and produce what we call effector cells. Effector cells are going to go throughout the body and do away with this antigen. They're going to be looking for it. They're going to be looking for it to mark it, to consume it, to get rid of it. After the antigen has been dealt with, then you have the secondary response where these will go into memory cells, so you have them floating around like this one, and antibodies to make sure that you're going to take care of anything that happens within a time period before these are degraded by the body. So you've got this second line of defense. Now, what does that actually look like? How does that translate or work in nature? Let's look at that. So, when we look at the antibody concentration in days, once an antigen has been exposed to the body, it's very interesting looking at the difference between primary and secondary response. So here you've got exposure to antigen A. This is the first time this has ever happened to this body. At about 5 to 7 days, you'll start to get an antibody resistance starting to be built up. Your body is fighting that. Those effector cells are doing their job. Your antibodies are starting to take out those antigens as well. And eventually, you get that healing that will take place. So somewhere in here, from point here to some point over here, you'll start to feel better. Notice the antibodies, though, are still going to be present for a while. They'll start to decrease a little bit over time. But they get to a point to where they haven't decreased to being non-existent. They're still around in the body. Well, look at this second exposure to antigen A. So now you've been exposed to it again. Look at this response. Whoa, right up here, the concentration of antibodies exponentially grows all of a sudden. This allows your body to fight that off without going through all the things you went through here with being sick. So let's say this was the flu. Influenza, you get it, you feel horrible for 7 to 14 days. Your body eventually fights it off. It stores these antibodies so that if you come in contact with the flu again, you get this immediate huge response to take out that antigen. This is why we suggest for you to get the flu shot. So we expose you to dead or weakened influenza. Your body still goes through this primary response, and then you've got these around as you come in contact with the flu during the flu season. So then you get the flu, maybe. You may have a day or two of feeling bad, but look at this response way up here to take that thing out, and that way you don't deal with the full-blown flu should you come in contact with it. Notice at this same point, you're also being exposed to antigen B. You got that same response of 5 to 7 days. Antibodies eventually will start to kick in, so on and so forth. So you get this little hump here to get you through fighting it, and then you get the protection for later, which is considered to be that secondary that secondary response, so that if you're exposed again, you get that immediate kick into let's destroy this thing before it causes any more problems in the body.